Hello everyone, my name is Miss Eileen and I'll be providing you with your lesson for today. I'm going to begin with sharing my PowerPoint with you, and I'm going to make myself a little bit bigger, that way you can see me. Okay. All right, so at the beginning of this PowerPoint, I'm going to show you a few tasty treats, and I want you to pay attention to what's similar about each of them. Okay, so here I have a Hershey's bar. There's also a Kit Kat, cookies, waffles, tangerine, a donut, pie, and pizza. All right, and so here's a clue about what's similar between each of them and what we're going to be talking about today. Okay, so what is similar about the food shown? I'll give you a moment to think about that. Okay, so hopefully you've discovered that they're all divided into equal parts, and these can be known as different types of fractions. So the Common Core State Standard is shown above, and this says that we will recognize and generate simple equivalent fractions like 1/2 equals 2/4 and 4/6 equals 2/3. And we will explain why the fractions are equivalent by using a visual fraction model. And there will be several visual fraction models that we will see and practice using today. And our learning targets and objectives will be identifying fractions with visual fraction models, use shortcuts to find more than one equivalent fraction, and be able to match up equivalent fractions, and we'll all gain more confidence with fractions. Okay, so what is a fraction? A fraction is pieces of a whole that are divided into equal parts. So here I have different fractions, and as we can see, there's different pieces of these wholes that are divided into equal parts, and they all represent different fractions. So what's a numerator? Right, so this is going to be the top number of a fraction, and furthermore, it tells us how many pieces we have. So 5/16, we see that there's 5 pieces in 16 wholes. So the denominator. The denominator is the bottom number in a fraction, and this tells us how many equal pieces the whole has been broken into. So using the same fraction, we see that 5/16, there's 16 equal pieces that the whole has been broken into. And so here, furthermore, we see 3/4. Fourths is going to represent how many equal parts the whole has been broken into, 1, 2, 3, 4. And 3 represents how many of those equal parts the fraction contains. So we have 1, 2, 3, 3/4. So equivalent, does anybody know what equivalent means? Sounds like equal. Okay, so equivalent fractions are fractions that appear to be different in number form, but actually they have the same value in a visual representation. And I know that can seem a little complicated at first, but I'm going to explain it to you a little bit better. So here we see 2/3 and 6/9. As we can see that the same area is covered in pink, which shows that these two fractions are actually equivalent. And although they appear to be different in number form, with their visual representation, they're actually equal. So these are all equivalent fractions here. We have 1/2, 2/4, 3/6, and 4/8. So in order for me to explain it to you a little bit better, I'm going to ask you a few questions. So how many pieces is this broken up into? 2, right? And how many pieces are shaded? 1. So that's why we have 1/2. And here we see that there's how many pieces that are broken into? 4, right? And 2 are shaded, so that's why we have 2/4. And this next one, we see that there's 3 pieces, right? And how many wholes? 6, so that's why we have 3/6. And then the next one, how many pieces are shaded? 4, right? And how many total? 8. So we see that 1/2 is equal to 2/4, 2/4 is equal to 3/6, and 3/6 is equal to 4/8. And they're all equivalent fractions because the same area is shaded, as we can see. So here, furthermore, we can see that 1/4 equals 2/8, which also equals 4/16. And in these pictures, you can also see the same thing, that the area of each whole piece is shaded equivalently. And the shortcut, in order to get to the next equivalent fraction, you can multiply times 2. So here we see that 1 times 2 equals 2. and 2 times 2 equals 4. We'll do the same thing to the bottom. 4 times 2 equals 8, and 8 times 2 equals 16. Okay, so for our guided practice, I want you guys to follow along. You can bring out markers and a piece of paper and follow this. Okay, so we'll be doing this together. We're going to start off with 4 over 7. Okay, and just like I showed you before, we're going to multiply the top times 2. So 4 times 2 equals 8, right? So we're going to write 8 and multiply 7 times 2. And what does that give us? 14. So we're going to write 14. And I'm going to write an equal sign showing that 4 over 7 equals 8 over 14. All right, and so now I'm going to take a different colored marker and write times 3. So 4 times 3 equals what? 12, right? So 4 times 3 equals 12. And I'm going to do the same thing to the bottom. 7 times 3 equals 21, right? Okay, 21. And so I'm going to draw the equal sign again and see that 8 over 14 equals 12 over 21. And we're going to keep going. So 4 times 4, what does that give us? It's going to give us 16. And we're going to do the same thing to the bottom. 7 times 4. What's that going to give us? It's going to be 28. And I'm going to write the equal sign showing that 12 over 21 equals 16 over 28. And getting even bigger, times 5. 4 times 5 will give me 20, right? And so we're going to write 20. And at the bottom, again, times 5. 7 times 5 gives us 35, correct? And I'm going to write the equal sign showing that 16 over 28 is also equal to 20 over 35. And next, times 6. 4 times 6 gives us, it's going to be 24. So we're going to write 24. And once again, at the bottom, 7 times 6. It's going to give us 42. Okay, and I'm going to write the equal sign and circle it, which shows that 20 over 35 equals 24 over 42. And here it's going to get fun. We're going to add a little drawing. It's going to be a tail. Now I'm going to outline the body at the top and at the bottom. And I'm going to use black and create some eyes. As shown. And maybe you can see what this is going to be already. Or maybe you don't know. I'm going to close the mouth and I'm going to create some lips and some fins. And hopefully this does look like a fish to you. That was the point of this. And as you can see, whatever we did to the top, we also did to the bottom. And these are all equivalent fractions. And so now that we did that together, I want you guys to focus on this worksheet on your own. And you can see our direct instruction example was provided up here for you to look back at. And I want everyone to pay attention to number 5 real quick. We have 12 over 12. And let's say we multiply top and bottom by 2. It's going to give us 24 over 24. But what's unique about this fraction is that there's going to be 12 pieces of 12 wholes, which actually gives us one. It's going to give us one entire whole because each piece is going to be shaded if we put it in a visual form. So this one is actually equal to 1. Okay, so I'll have you guys continue. Since there are 10 problems, it should take you no longer than 10 minutes, hopefully like from 7 to 10 minutes, because in order for you to find equivalent fractions, all you need to know is your fast multiplication facts. All right, and so next, we're gonna check for understanding. This is gonna be a quick assessment. So fractions that name the same amount are called whole fractions, equivalent fractions, numerators, or denominators. Right, so these are going to be equivalent fractions. Okay, so look at the rectangle. If you were to write it out in a fraction form, how would you write it out? 2 over 2, 6 over 2, 2 over 6, or 6 over 6? Right, so this is going to be 2 over 6 because 2 pieces are shaded out of the 6 wholes. All right, so look at the circle. If you were to write it out in fraction form, what would the denominator be? 2, 6, 8, or 10? I'll let you count those for the denominator. Right, so there's 10 because there's 10 equal wholes divided here, representing the denominator. Okay, so these are going to be true and false questions. Equivalent means almost the same. Is that true or false? Right, so this is false. Equivalent means the same or equal to. Next, these two fractions are equivalent, 3 over 9 and 6 over 9. Is this true or false? False, right? Because here we see that 3 over 9 and 6 over 9, they're not equivalent. These two fractions are equivalent, 4 over 6 and 12 over 18. Is this true or false? Okay, this is true. So we can see that 4 over 6 and 12 over 18, when we multiply the top and bottom by 3, these do in fact equal. Okay, and so sometimes you're gonna have to do it in your head real quick and think about, okay, what can I multiply in order to get me to 12? 3, and is that gonna be the same to the bottom? 3, right? And this also works with division. You can divide 12 by 4, that's 3, and 8 by 6, and that's also 3. Okay, and that'll help you with the game that we're about to play. So in this game, we're gonna have a few different cards, and this can be around 2 to 4 people. So this is gonna be a matching game. And the way that you play is each person gets a turn to flip over 2 cards. And if they get an equal fraction, then they get to hold on to those cards. And they're gonna keep going around until all the fractions are collected, and whoever has the most fractions wins, okay? So I'm gonna explain the game with you as we play. So first we have 1/2 and 3/4. So are these equivalent fractions? No, right? So I'm gonna turn them over. Next we have 9/12 and 3/4. Are these equivalent fractions? Yes, they are. So this person is going to claim them. Next, 3 over 18, 4 over 5. Are these equivalent fractions? No, so we're going to go to the next person. Next, 3 over 6 and 1/2. Are these equivalent? Yes, so this person gets to keep them. Next, 4 over 12 and 1 over 6. Are these equivalent fractions? No, so we're going to turn them over. Next, 4 over 5 and 2 over 6. Are these equivalent fractions? No, we're going to flip them over. Next, we have 2 over 3 and 6 over 9. Are these equivalent fractions? Yes, so this person's going to take them. 4/5 and 1/6, are these equivalent? No, so we're going to turn them over. Next we have 2/6 and 1/6, are these equivalent? No. And then next we have 3/18 and 1/6, are these equivalent? Yes, so this person will claim them. Here we have 4/5 and 8/10, are these equivalent? Yes. And next, 2/6 and 4/12, are these equivalent? Yes, they are. Okay, and so whoever claimed the most cards wins. And I know that that might have seemed a little complicated to tell whether or not the fractions were equivalent because you had to do the math in your head. So I'm going to explain it a little bit further. So here we have each of the equivalent fractions. 1/2 is equal to 3/6, 1/6 equal to 3/18, 8/10 equals 4/5, 6/9 equals 2/3, 2/6 equals 4/12, 3/4 equals 9/12, okay? And furthermore, in this video, I will show you what we are doing. So here we have 1/2 equals 3, or 1 times 2 equals 3, 2 times 2 equals 6. Over here we have 1 times 3 equals 3, 6 times 3 equals 18. And here we're working backwards. So 8 divided by 2 will give us 4, and 10 divided by 2 will give us 5. Again, we see that 6 divided by 3 will give us 2, and 9 divided by 3 will give us 3. And at the bottom, 2 times 2 is 4, and 6 times 2 is 12. And 9 times 3 is 9, and 4 times 3 is 12. Okay, and so that's how we'll be working on the fractions in our head to be able to move back and forth. And of course, if you need a little bit more practice, you can also draw out the fractions. However, this only works with smaller numbers, okay? Or it's easier to work with when given smaller numbers, okay? And that concludes our presentation. I hope you enjoyed it, and I hope everyone's safe at home, and we will continue learning about fractions later on, okay?